Hey, what's up guys? Thank you very much for being on Electrica. I really appreciate that. Now, we have today forward, reverse, starter, control circuit. Now, this is what we want to do today. It's what I've prepared for you. Now, I have a circuit right here before me. You know very well that before we go to the table to do the wiring, we must go through the circuit, and if we can all understand this circuit, then definitely it will be good for all of us, okay? And it can also, make things easier. Now, before I go in further, I'll put for you the timestamps, so if you feel that you don't like this fiole, then you can go directly to the connection or at the table. It will be better that way. So, until then, for me. Now, we have different parts in this circuit. So, and this is a control circuit. So we have motor coils or contactor coils. We have light indication here. We have interlocks. We have start, stop, those buttons. We have emergence. We have overload relay. Now, we have like 5 stuffs that we have to break down right here. The one thing, we need to talk about the overload. Okay, we need to talk about the interlock, we need to talk about the control circuit, okay, the e-stop, okay, so, and the breaker. So you have the breaker, you have the overload, you have the e-stop, you have the interlock, and you have the control circuit, all right? All right, now, let us go step by step. The first thing we do is, let us talk about a breaker. So, we have a control breaker right here. Here. So this, it will help to protect your circuit. It will usually be a small amperage. It could be, like it depends on the rating of the contactor, but it can be 6, it can be 10, or it can be 15. It will depend on the rating of your control circuit, okay? So you have a breaker. It must incorporate it here such that if you switch it off, if anything happens, maybe if the coil gets burnt, anything happens in the control circuit, this breaker will protect it. So it can either be a fuse or a breaker, okay? All right, so let us talk about the overload, okay? Overload relay. So this is an overload relay, and overload relay protects the motor against short circuit and overload current, okay? And this guy has got 2 contacts, okay? Now, normally open and normally closed. Now, usually normally closed, it's what breaks the circuit. So you have 96, 95 around here, which is the same as on this overload relay, okay? So our circuit goes through 96 and 95, such that if there is any fault condition in the entire system, this one will detect it, okay? And then the bimetallic strip will be operated and it will trip the entire circuit. Now you see this, it is protecting the motor, okay, by disconnecting the circuit, okay? So the motor is developing a problem, and what happens is that this senses it, then it operates the bimetallic strip, which opens the contact, and the same contact is the one that controls, or the one that supplies our control circuit. But the breaker, as I said earlier, it protects only the control circuit, just in case there is a short circuit in the control circuit, okay? All right, now, as we talk about this overload relay, so we have these 2 contacts here that I'm showing on the overload. Now we have 95, 96, 97, 98. So the closed contact 95, 96 is this one here, okay? So when you supply your circuit, it means that you give 95 a voltage here, and then you loop to 97, okay? Then the other end of this contact, which is 96, it's what, here, it's what now controls our circuit or supplies our circuit. Now 97 goes through to 98. So at the other side of 98, it's where we connect our trip light. Okay, the way you see that. All right. All right. So that's how the overload relay protects the circuit. Now we will incorporate it in our circuit. It's good that you can understand it a bit early, such that we can, go forward. Now let's talk about the e-stop. Okay. So you have an e-stop here, which we have put right here, and you see it's before the circuit. So we have a fuse, an overload, and then an e-stop. Now, you can operate your circuit without this, okay? But this is a safety device. It's a safety switch. Now, you can use it in the situation where this kind of circuit has been applied, or it's controlling a motor, which is maybe running a machine, okay? It could be a lathe machine, okay? It could be a maze milling machine, any kind of machine that is being run by an induction motor, okay? And it's operated by this forward and reverse, or it can be a crane, an overhead crane, okay? All that you have to incorporate this in the circuit, and you can have multiple of them. For example, if you're operating a crane and on the wire remote, which you're using literally like this, operating that crane which is going back and forth, you have an emergency there. But also in the field somewhere, in the field I mean, if it is a workshop, other position is other than where the machine itself is. So you can also put multiple one. For instance, if there is any fault condition that happens which is endangering either you or the installation, then definitely anyone can press. If the person who is operating the machine can't reach this, then the other people at the other end, they can always reach the e-stop and press it. So that's the purpose of this e-stop in this circuit. Okay. Now, let us talk about the interlocks. So these are interlocks in the circuit. So you see, this is a forward side. This is a reverse side. Okay. Now see, from the start button through an interlock, which is from the reverse side, then to the coil of forward. Okay. The same thing applies here from the start button. Before we go to the coil, we have to go through the F, or the forward, contactor, auxiliary, such that we come to this coil. What are we trying to achieve? We achieve here that if the reverse contactor is running, it means that even if you try to press or you try to engage this forward contactor, it will not engage, because now if the reverse contactor is engaged, definitely this contact will be open. So it means there will be no any current that could go through this line to energize F. Okay. So you have your auxiliary contact where you can do the interlocking. So what does it mean? This is the reverse contactor, and then this is the forward contactor. Okay. To energize the reverse contactor, it means that before a wire goes to A1 of the reverse contactor, it should pass through the forward normally closed contact first here, then it goes right here. It means that if the forward is running, it will open the normally closed contact, and meaning the reverse contactor will not engage even if someone pressed the start button. The reverse also is true. Okay. All right. Now let's go to indication. Now our circuit, it's good to have indication on your circuit. Now here in our indication, we have some lights right here, and these lights, one will be showing the trip status. So let's say something has happened to the motor and the circuit has tripped, like I explained on overload relay. Now when this circuit trip, this light will indicate. So you come and check and see that yes, there is a problem. Now The other thing is the status of running, either forward or reverse. So we have an indication here. We have a light which will go on if the reverse contactor is running. We have a light which will go on if the forward contactor is running. That's why you see from our circuit here that if this coil is energized, it will, also supply this light here. If it's off, this light will be off. Okay, same as this one. Now, if we go to the other indication of stop mode, if this circuit is in a stop mode and no contactor has been energized, okay, meaning that this stop mode, this light will indicate, this light will be on, okay? And how are we wiring that? On the same contactor, actually when you're putting multiple indication, you must make sure that your contactor has got multiple auxiliary contact, okay? So, for example, if we want to put this status here, what do? This is what we are going to do. We are going to use this normally closed contact on each contactor. First, we will feed an L from one normally closed contact on the F contactor. Through it, then we go through the normally closed of the reverse contactor, then to the light, okay? Meaning, if these contacts are not energized, then this light will be on because both the contacts are closed, okay? However, if one contactor has been engaged here, press here, and it has been engaged, definitely this light will go off, okay? So either contactor can switch off this light. It can only be on if both contactors are de-energized, okay? So that's it. That's the simple thing about this circuit. Now, if you can try to follow this a little bit, so you have your breaker here, then we go through the 95, 96, we go through our emergency stop, we go through our stop, which is normally closed. Then our current will hang here. So if you press here, this current will go through the normally closed reverse contactor, then it will energize the coil of forward contactor. Now, when you release this button, this holding line here, it will, because the contactor is closed, definitely this normally open contact will close. And when you release here, this will remain closed, and then our current will have a second path here to the coil. The same thing will happen to the reverse if you press the reverse start button, okay? So I hope this small theory here has, given you more insight about how, the circuit works and how to indicate, okay? So let's just go to the bench and then do the practical part of it, okay? Now, as from our board, so we're going to use these contactors here that I was using on a board earlier, okay? So these are two contactors and they have been interlocked mechanically. So you're able to see this thing in the middle here. It's a mechanical interlock. And to prove to that, you see, if I engage this contactor, I can't push this. If I push this, I can't push the other. So you're able to see that they are interlocked mechanically. Now, let us start wiring. So, okay, so this is our emergency, start, stop, forward, reverse, okay? All right, so I have some different wires here. I've been already arranged them. Okay. All right, now what do we begin with? So first you have to understand that we have four buttons here, 1, 2, 3, 4. Now, this is our emergency. Our power will come in from here. We are not going to use this overload relay simply because it can't enter our contactor, but take the concept which I used on the board, okay? Now, here is this emergency, so our line in will come in here, and then when you see this side, this is the line out, and then it will enter the stop, okay, here. Now, from here, from the stop of the other side, it comes and loops on the start button is, okay? All right, so you'll have a schematic on your screen as you follow along. Now, this is the wire from our breaker, which has red right here. And this one, since it's the one supplying our emergency switch, we will have to put it here. Make sure it's tight. Okay, that's one. Now, we are going to first wire one side first, okay? So, we'll have one wire which is supposed to be holding the contacts, okay? But before that, I want to show something. So, this, we are going to use one of these, okay? So, this is going to be our forward. I'll put it here. And since this is our forward, so I'll just bring it here, okay? And you will see why. We said in a previous video that we want this current to go through, before it goes through this contactor here, because we want to energize this very contactor, which is forward, KM1. But we have to go through KM2, which is our reverse contactor, okay? So I have this wire here. This is normally closed, okay, here. Now you see, so what we are going to do is to take this wire here and supply our coil. So it will enter this side, you see, and then it goes to the coil of forward contactor. So right here, okay. Now see, we have to energize this contactor. Now if I have to give this contactor neutral, okay, now you see we have wired one side from our reverse button, from our forward button here to KM1 just here, which is any O of the forward contactor. Now from here we've looped to NC of the reverse, through it, then to the coil of the forward contactor. Now let me show you something. If I try to energize this contactor, you see? So this contactor energizes, but it doesn't hold, okay? But doesn't hold. Now, what we have to do is now to make it all hold, okay? So to make it hold, this is what we are going to do. We need another wire here, and we will couple it here. And this wire will enter here. We'll feed it normally open, so because retaining goes through the normally open of the self contactor or of the forward contactor, okay? Now, because I've added this wire here, only this wire here, if I try to press the forward contactor like this, it holds because of this, okay? All right. Now, having done that, let us wire the other contactor also. So we're going to wire this, the reverse contactor. So here also, we're using another blue wire here, and it will connect to the reverse, okay? Okay, now from the reverse here to the reverse contactor. Now the reverse contactor is here. We need the normally open contact here, the same way we did here. Just enter it here. Now because we want it to go through the forward contactor, we need to get a wire here and we loop from here. and this will come here to the normally closed of the forward contactor. Now, okay, now for us to be able to energize this contactor, we have to go through the forward. So we are connecting another wire here. And then this one will be connected right here, A1 of the reverse contactor. Let's connect the neutral. All right, neutral done. So if we try to energize the reverse contactor, see, it engages, but it goes out. If I try to do the forward, you see, forward holds, but reverse doesn't. You know why? Because it doesn't not retain wire. So we're just going to get this wire here, and then we pick current from here, we feed it here. And we need it here. All right, now let's see if we press the forward contact, engages. If we go to the reverse, it engages. Okay, now we can try to see this emergence button. So if you press this, the emergence button will de-energize, okay? And you cannot start the circuit again unless you reset the emergence, okay? All right, that's it. Now let us see how you add the indicator light. All right, so we have these lights here, and let us see how we add them. Now, one is going to be for forward, reverse, and stop. We are not going to do the trip one simply because this device cannot get here. So, but you get the theory from the board. Okay, now what do we do first? We need to connect right here a neutral. Let us begin with that. We just have put this wire here. Now the neutral is done, and let us connect it. Okay. All right. Now, since we've done that, so we want to go to connect a light for the forward, light for reverse, and then light for stop. Now, okay, so we have all the hot wires right here, okay? Now, first, let us connect these two wires for forward and reverse. Now, this is easy. We're just going to, because this is forward, and then this is a reverse. So we're just going to put this wire here. And then the second light, it will come here, okay? This is a reverse light. Okay, that's now done. Now let us look at the stop. This wire here, we need the stop. Now, as I said earlier, when we are at the board, we just want these two normally closed. These two normally closed on the forward and the reverse contact. And how do we do them? See, here we have some supply here, which is coming to the retaining line, okay? It's not being controlled by anything. So we can pick it from here. And then we feed it here. NC of the forward contactor, that's where we are feeding this. Now, what else do we want? So what we want now is, let us get it from here. This is now, we are completing this. This is NC of the forward contactor, okay? And this NC of the forward contact, it will come through the NC of the reverse right here. Now, we have our final output. Remember, we've picked supply from the independent wire here, which goes to the retain all the two contacts. It has come all around through the forward, all around through the reverse. Now this is all right, so that's okay. Now I want you to see, I want us to dim some light here such that we are able to okay, now my lights are off and I want you to see. So you are able to see that the stop is on. Now if I press forward, the forward light goes on. Okay, I stop, the stop light goes on. I go reverse, the reverse light goes on. Okay, I go stop, the stop light goes on. I go forward, the forward light goes on. Okay, now if I press the emergence, the entire system goes off. Okay, how about that? Hey, thank you very much for watching. I really appreciate that. If you've come this far, then I'm sure you've gained a lot. Now, if you're new here, my name is David. Thank you very much for watching. Please don't forget to subscribe, to like, and share. Now, if you need a circuit for this forward and reverse that we've just done, I'll put a link in the description and also in the info card so you're able to download it from my website. The website is electrica.org. Okay, I appreciate it. Thanks very much for your time. Until next time, I'm out.